comparison between product and process. The next one I'll introduce you is the fixed position layout. From the wording itself, it tells you that there's a fixed position. What I mean by fixed position? It means the product cannot be moved. Fixed position layout, it means that the assembly of your products cannot be moved. So normally, it is something very big, like ship, like aircraft, that you cannot move it. You cannot move it very far. Right? In the space there, you can do all the assembly in one space. Right? So for fixed position, they are usually for those very big projects. For example, aircraft and ship. So this is a ship construction. In the fast forward photo, just in case you never seen how people build yacht before or a ship before. Right, so you can see the product is on one fixed location. This is a fixed position layout. And then commission it. Okay. So let's talk about fixed position layout. So since your products cannot be moved, the other things, they move it to the production sites. For example, equipment, worker, material, resources, they move into the production floor. Okay. And the workers on the sites, they are very skillful. And you can call them as a specialist or special tasks. Worker that able only do special tasks, or we call them specialists. Usually they can find in the fixed position layout. Means they will arrange a schedule, and then that particular time, that particular worker, expertise or specialist will go in there and fix the problem. Okay, each individual time frame, you will see different people appeared on the production floor. The rest you can read, quite a long sentence here. It's about cost. All right. So fixed costs can be low. The fixed cost can be low because you keep repeating producing the same products. For example, aircraft manufacturer. The equipment is there, right? So you produce one, you produce two, produce three, also using the same equipment. So in the long run, your fixed cost is very low. However, your variable cost is more on the workers and some specialized equipment you need to lease. This one fall under variable cost. Okay. One of the things that contribute to variable cost is your labor cost. Why labor cost is very high? Because you're employing specialists. You know that professional, they are very high cost, right? Okay. We have done with the layout, right? We have seen a few type of layout. Right. Now we go into designing. Again, this section is very interesting for those like to arrange things, right, and keep things in order. So the first definition first. So the objective of doing the process layout is to minimize costs. Right? The objective of the process layout is to minimize costs, especially in material handling. And you try to relate how to minimize material handling is that the movement of your factory floor. Okay, how do you move your material will be the main focus of process layout. This one you can read. Process layout is more on controlling the time to move your material. Okay, this is one of the visualization. What mean by material handling? Means you move your material from one station to another station. You can use forklift, you can use labor, you can use robot, and so on. Right? This is the logic, the statement behind the logic when you do planning, especially process layout. You will put department that link to other department in the center so that they shorten the distance travel to the department that related. Okay? Or you can say that you always seek the closest distance for the process. You always shorten the distance need to travel in the whole process. You spot A to B, B to C, C to D, which one is the shortest and how you minimize the time travel from A to D, for example. Okay. We will use two techniques here. Today we'll do one of it. Two techniques to design process layout. We will do block programming, block diagramming, and relationship diagramming. Okay, today we look at block diagramming first. All right. What is block diagramming? Just for info, relationship diagramming will not be the focus of our module. So we are focusing on block diagram. I'll still show you what is relationship diagramming later on. We'll focus more on block diagramming. All right, now there are some steps when we do block diagramming. These are the proposed steps. First, you look at what is the movement between departments. Meaning before you solve, you walk into the production floor and observe what is the current movement inside the factory floor. You predict the movement first. Means you go and watch how things move around. Then you record. Oh, okay, B to when the material come to point A, or then you will go to C. Or when the material come to B, or you go to D, for example. You do the predicted movement in the department, between the department. Okay. And then we will use something called a chart called load summary chart. For block diagramming, you need a help of a chart that you predict the movement. Meaning you go and observe the movement in the production floor, and then you put the data into the chart. That chart, we call it load summary chart, or just chart. Okay, later I'll show you what is this chart. Next, there's a calculation involved there. Right. Later we will show you. First, you observe the movement, come up with a chart, or normally in the exam, this one we will give you. What is the load chart? Then you need to do some calculation of the movement. Okay, some movement. For block diagramming, to define the calculation for movement, we use composite movement. Composite means there's a mixture of movement between department, and then you do some ranking. You do some ranking of their movement. Okay. First you observe, you get the load chart. Next, you do calculation for the movement, and then you do ranking. In the calculation later on, you will see some symbol. This symbol with double-headed, it means if you see A double-headed arrow, B, it means process A to B and B to A. It means go and forth. If only see one arrow, let's say arrow to the right, it means A to B only. But if you see double arrow in your calculation, it means you're considering one process to another process and process back to another one process. Huh? It is mean go and forth or back and forth. Okay, so this is a special symbol that you'll see in block diagramming procedure. The third one, you draw a new arrangement just to explain what makes sense or what is the argument that new arrangement will give you shorter times, more efficient, and so on. Okay, so involve 3 steps. First, observe, find the load chart, or in the production floor, you will create the load chart for your manager. But in this case, we will give you the load chart. Right? Then you calculate the movement. You involve something, you calculate, and then the top movement, maybe A to B, you need to travel 10 times. B to C, maybe 1 time. So you rank based on the number of travel. Then after that, you group them into certain pattern and you draw them up. Okay, let's start. Okay, one more definition in the calculation. One definition called non-adjacent lot. Non-adjacent lot. Later I will explain. At this moment, you just accept there's a new word coming in called non-adjacent lot. Okay? Meaning, if you see this one, there's a non-adjacent and there's an adjacent lot. So non means it do not meet that particular definition. I will explain that one later. So far, just have some preparation. What is going to happen? Later, you will see a load chart. You do calculation for the movement, and then you will create a new layout using the adjacent and non-adjacent data. Okay, so these are the basic 3 point or 3 steps when we do block programming. Okay, with that in mind, let's start look at one example. Okay, try to read the statement that you have here. So a certain company, this company, so-called Barco Incorporation, makes bug scraper, processing equipment that strip the bugs off tree and turn them into nuggets or much for cartridges. And there are few processes inside the facilities to assembly the bug scraper. It's a small job. It's a small shop that employ 50 workers only and arrange into the 5 departments. First department, they do cutting. Second, they do about sheet metal. The third one, they do machining. The fourth one, they do painting. The last one, do assembly. Maybe some of you don't know what is bug scraper. I give you a video so that you know what is a bug scraper. Right? This is a bug scraper. Mean you take off the bug from the branch here. Okay, the bug will fall down and then you send the nugget and bug to the garden. Okay. Now again, this is just a very big machine. It can be a lot of size. But what I want you to show is what mean by bug scrapers. It's a machine to remove the bug from the tree trunk here. Okay, it can be a lot of different mechanism, but the function is to remove the bug here. But this question does not necessarily referring to this kind of design. It just gives you some idea what is this company or this scenario give you. And this scenario, this factory have a lot 5 processors here to process a machine. Again, we don't have a very specific design here. It's just that they produce a machine that involves 5 processors. That is more important. Okay. Okay. We continue to read on, and if you have the tutorial handout, you have all the statement here. I just explain it line by line so that you understand what is happening. Huh? So the last page here is to tell you what the company do and what are the basic process we have. Next, I give you a more detailed information. So the average number of loads between the 5 departments just now was given in a load chart. This is called load chart. Okay. What can you find in the load chart? You can find the department on the column and row. This is from and to department. It means, how do you read this load chart? You have all the numbers here. 1, if you start from 1, from station 1 or from department 1 to department 1, there's no activity there. Department 1 back to department 1, there's no activity. It's just a intersection point. Let's say I pick this one, right? What does this 100 mean? It means from department 1 to department 2, you get a loading of 100 movement. And what about 1 to 2? And you send, let me do it slowly. You send the item from department 1 to department 2. There's a 100 movement here. If you use the go and back arrow, it means you send your item from 1 to 2, right? It must be from 2 back to 1 also. So you can read from here or you can read from here. For example, if I refer to 1 to 2, right? Department 1 to department 2. You can read from this column also. Department 1 to department 2. There's no movement back to department 2. So it can be one direction from 1 to 2 from this side, or you can read from the top 1 to 2. Okay, all these are movement. All these are movement number. And our objective is to reduce the movement between the section. Okay, this is about load chart. If do not see any numbers, mean no movement, no relationship between the station or department. Okay, so this is about load chart. Then you continue to read, it gives you more information. The current layout of the facilities is shown schematically on the 2x3 grid. What mean by 2x3? You know grid, right? We have row and column. Row and column. Meaning you place your process or equipment in 2 row, 3 column kind of setting. You see there's a 6 point there, right? If you do 2x3, you get 6 possible position, right? 1, 2, 3, 4, 5, and number 6 is here. You have 6 possible locations to put your facilities. And your facilities you contain within this 2x3 grid. So your answer, you can only play chess or you can only play movement within this 2x3 grid. Okay? So in exam, when exam give you 3x3, 2x3 grid, make sure you don't run outside. Meaning you don't give me answer that outside the grid. You run outside the grid means you run outside the factory area. It means you don't solve the problem. You actually create problem for your boss. Right? Right? So this is the idea that you need to bear in mind when you solve these kind of problems. We will specifically give you a limited space to move around. In this case, we give you grid. 2 times 3 grid means you have to be careful. 2 times 3 means 2 row, 3 column. Row and column, make sure you have some clear idea what is row and column. 2 means 2 row, 3 means column, 3 column. What happened if I flip this one? It will be different setting already. If I flip this number, 3 times 2 mean I have 3 row, 2 column. Any idea? Any question about grid? It's like a matrix. It's like a matrix. It will be like a matrix, row and column. Everyone good, huh? Everyone good about this one, huh? It's a little bit tricky, and just for your info, I like to play around with these numbers. So if you're not sure, make sure you rewatch my video one more time. This is row, this is column. Row, column. Okay. Notice that there is quite a bit of flexibility in the facilities as indicated by 6 possible locations, or we call it intersection, that I showed you just now. Although the number here is 1 to 5, there are 6 possible locations that you can play with. There's one more location you can put here. Meaning you have 5, if you play chess, you have 5 chess pieces, but you have 6 locations you can play. All right. Available for 5. Okay. In addition, the forklift used in the facilities is very flexible. Means the way you move your material is very flexible. There's no restriction. Allowing horizontal, vertical, diagonal movement of the material. What does it mean? You have 6 positions there. You can move up, you can move right, you can move down, or even you can move diagonal. You see number 3 to number 5, you can move diagonal. This is called diagonal. Or you can move 1 to 5. You can move in this way. Okay, you can move 2 to 4 diagonal. Okay, so this is the rules of the game that you need to know. You need to play within these rules. Means the space that you have, the movement of your chessboard or the movement of your facilities or your department. You can move up, you can move down, you can move left, you can move right, you can move diagonal. Your objective is to find the most efficient or effective movement for the fluctuative fund. How do you arrange? Because you have all this movement here. You want to minimize the movement inside your factory. Okay? So this is our statement. So how do we start? We start solving already, We start solving already. Okay, so this one more. Okay, you can read lah. So management anticipate a new bulk scraper plan will soon be necessary, and would like to know if a similar layout should be used or better layout can be designed. So this is the old layout, and the owner is quite rich, so he want to build another new factory. So he just asks you whether it is possible to redesign a new floor and then put a new design in the new factory. You are asked to evaluate the current layout in terms of non-adjacent loads. If needed, propose a new layout on a 2 times 3 grid. So you are mentioned that you are restricted to 2 row, 3 column grid that will minimize the number of non-adjacent loads. I will introduce you non-adjacent load later on when we do the calculation. Let's start. This is our limitation of our space. And we start to identify 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 represent department. Right? You have 1 to 5, 1 to 5 department, and there's lots of movement between the department. Okay? Let's do some calculation. First, look at the layout. and we start to do some calculation using the back and forth arrow. Let's try to calculate the movement between the department. Right. So this is quite scattered. The data is quite scattered, and it was collected based on individual station. It do not see the whole picture yet. Right. So just give you some idea how to calculate. For example, we want to find the composite movement between department 1 and 3. What is the total movement you have? You go and look at the axis here. We start with 1. Okay. Between 1 and 3. So where is the numbers? Between 1 and 3. Department 1 to Department 3. Okay. Department 1 to Department 3, you get 50. If you want to use the back and forth movement, this is only one movement. 1 to 3. What about the coming back? 3 to 1, right? There's one more here. 3 back to 1. Again, I repeat. When you need to find the composite movement between department 1 and 3, you need to consider go and forth. You fix with this side, you fix with number 1. Department 1 to 3, 1 to 3, you get 50. The item was at number 3. So you need to go back. You read 3 back to 1. What is the total of composite movement? This one plus this one, you get 110. Okay. If the question asks you to find composite movement between department 1 and 3, how you find it? You read from 1 to 3, you get 50. Imagine the item sent back to department 1, 3 back to 1, you get 60. Composite movement, combine the two, 50 plus 60. I highlight with different color here. From 1 to 3, you get 50. From 3 to 1, you get 60. Total 110 loads of material. Any questions so far? Try to understand what we're trying to do here. Do you understand how you get 110 loads of material from this paper? By focusing on movement between 1 and 3. Okay, give you about 10 seconds to look at the formula, to look at the table, look at the red color and chocolate color, and the blue color answer we are able to relate. So far, we haven't touched on this grid yet. We look at the table. Clear? Clear? Good? Sarini, you okay?
Clear, sir.
Okay.
Yes, sir.
All right, good. Now, this is how we calculate. Okay. I assume you understand this is an example of one movement. Let's do analysis for department 1 until department 5. We need to build a table. Okay, we need to build a table. After you build a table and then you put in all the composite movement, what we do, we will rank them from highest to lowest. Okay, I do one by one. I will build a table. Of course, you can build a long table because I don't have a space here. So I cut my table into half. Basically, you only need 2 columns. You only need composite and movement. Because I don't have space in my PowerPoint slide here, I do another section. Okay. So after you watch the load chart, next you build a table, composite movement, and then you start analyze from number 1. You can do it systematically or you can do it in your own way, but I like to do it in a more systematic way where I don't miss any numbers. First, I enter the chart from the left. I start with number 1. I put a ruler or I just draw a line just to remind myself I'm looking at number 1. And I go each station. First, I look at 1 to 1, meaning I send my item to station 1 and station 1 send back. There is no movement there. What I write 0. Okay, this is nothing, right? So I put 0 here. Okay, go and back. I use red and chocolate color just now, just to relate what we learned, right? Just to relate what we learned just now. There are 2 motion. Go and send it back. Red color, send it there. Chocolate color, I send it back. It explain the double arrow here. So as you can see, the 2 square put together, you add together, you still get 0. This is my way, right? This is my way. I do it in this way. Next, I continue to stay in department 1. I look at 1 to 2. Can you guess the movement? 1 to 2 movement and 2 send back to 1. 1 to 2, you get 100. Remember, you need to send back the material from station 2. So 2 to 1. There's no number there, but you still need to circle it. Although there's no number there, it's considered 0. So what is the total? You get 100. Write 100 in the chart. Okay? Any question? Any question? Next, I'm going to ask question for 1 to 3. I will ask this question to Harry Shyam. Are you there?
Yes, sir.
Okay, try to solve try to solve this one. What is the number of 1 to 3?
50,
The
sir.
rest, you try to check. What is the answer for 1 to 3?
50, sir.
1 to 350. We are talking about composite.
Yes.
1 to 3. How you get 50? You tell me.
Oh.
Station 1, you send to station 3, you get 50, right?
Yes, sir.
Right. What about the material? Why you stop the material at station 3? You need to send it back.
Sir. I need to add. Okay,
Add what?
110.
Correct.
From
Answer is
station
100.
1 to 3 and 3 to 1.
Yes, correct. The answer is 110. Because you need to send 1 to 3. Remember, you need to send from 3 back to 1. So 3 back to 1. So you get 60, 50, 60, 110. Okay,
sir.
yeah, good. At least you are aware. Next, we do the next one. 1, 4. Let me try. Anyone you want to try before I call your name? You can look at the question. Then I'll call out one name. It's like playing chess. You look at the movement, go back and forth. Okay, this question I will ask another Harry. Harry Prasad. Harry Prasad, what is the answer for composite movement 1-4?
Wait, sir. Is it 0?
Okay. So 1 to 4, there's no number there. And then remember to send back the item. 4 back to 1, there's no value there. 0. I do the last one. The last one will be 1-5. So, Ruven, are you there, Ruven? Ruven, what is 1-5 composite movement?
50, sir.
Eh?
50.
How you get 50? You tell me. 1 to 5, how many? Station 1 to 5, how many you get?
Oh, sorry, sir. 0, 0, 0.
Ah, okay, 1 to
Same
5.
entry, sir.
1 to 5 is 0. Then you need to send back from 5 to 1. So basically, there's two space here. 0, 0, 5 to 1. Okay. So I think I make the idea clear enough for everyone. So just to save some time, I will not repeat the space here. Huh? But of course, you can do one by one. So they are, if you do every single movement like this, you'll get 25 movement. Huh? You'll get 25 row to calculate. If you don't want to miss anything, you just go and do 25. But of course, there will be some repeated. Okay, we focus on the numbers. Huh? So we from, okay, go back here. So from here we have 1 to 2, 1 to 3 is 100. The rest 0 we are not interested, because 0 you cannot rank anymore, right? So we go for the next one. Again, I continue with okay, I have solved one already. Yeah, I go second row. I go second row. I go 2, 1. Okay, I go 2, 1, and from 1 back to 2. 1 back to 2. I get 100. Okay, so basically number 2 here, 2, 1, and 1, 2. Basically, they are the same as the first one, right? 1 to 2, 2 to 1 is the same. So I skip. Then you continue to do 2, 2, 2, 2, 0. I don't do it because it's 0, no meaning. I continue to analyze 2, 3, 2, 3. Then from 3 back to 2, 3 back to 2, 0. So I have 200 plus 0. So I have number there. The next number I write on my chart is 2 to 3. 2 send to 3, I get 200, plus 3 back to 2, 0. 200 plus 0, I get 200. So I just highlight for you lah. Okay, you're going to repeat this process until you get all the movement analyzed. Okay, so I'm not going to repeat all this now. You can do that in your homework, in your homework or revision time. Okay, I'm just going to show you the answer. So the next one, you analyze 2, 4. Okay, 2, 4, 2, 4, you get 50. Then send back from 4. 4, send back to 2, you get 100. So 50 plus 100, you get 150 right in the chart here. And continue to analyze because the next one is 0, 2, 5, 0, and then send from 5 back to 2. 5 back to 2, there's one number here. So 5, 2, check, is there any number here or not? So you haven't right? 5, 2, there's no, so you register one more input there. So the next one is 2 to 5, 5 back to 2, okay, 2 to 5, 5 back to 2, you have one number there. So register that number in the table. So 2, 5, you get 50. We have clear row 1, row 2. Continue with number 3. You analyze the same method. So you look at 3, 1, you get 60. And then remember to send back from 1, send back to 3. Okay, because here is 3 to 1, you get 60. Remember to send back 1 back to 3, you get 50. So this is 1, 3, and 3, 1, same, like this one. So you don't need to repeat anymore. So this one actually is repeated. 3, 1, and from 1 back to 3, you already calculated. This one already calculated. Same, 1, 3, 3, 1, same thing. You don't need to repeat. Okay, always check your answer. Always check your answer. Don't need to repeat the same movement. Then I continue. Then I continue to find lah. So just now 3, 1, okay, 3, 2, 0. Then I need to send from 2 to 3, 2 back to 3. I have 200. So 2, 3, 3, 2. Do I have data here or not? Yes. I have this data already, so I skip because I repeated this record already. So I skip 2, 3, solve. What about 3, 3? 3, 3. So 3 back to 3, 3 back to 3. There's nothing there. 3 back to 3, 3 means in the same location. Basically, there's no movement. Okay, 3, 3 basically no movement. So 3 to 4, you get one number, and 4 back to 3, 0, you have one number there. So you have 3, 4, 3 to 4th station. From 4th station back to 3, 0, 40 plus 0 get 40. Do the same. 3, 5, you get one number. But remember to send it back. 5 back to 3, 0. We have one more. 3, 5, you combine these two locations. And 50. So if you can see, is there any more or not that you can do? So you have done row number 3, go row number 4 and do analyze some more. Check with the same procedure. So there's one. Row number 4, there's one repeated here. Then 4, 5, you get 4 to 5. And remember to go back. 5 back to 4, you get 0. So 60 plus 0 gets 60. And then move to the numbers 5. See if you're already clear or not. 5, 1. Okay, 5 to 1. 1 back to 5, 0. So I skip. 5 to station 2, I get one number here, 50. What about 2 back to 5? 2 back to 5 is 0. Check if there's 2, 5 here or not. Yes, there's 1, 2, 5 record. So skip. The rest 0. 5, 3, 0. Send 3 back to 5. 3 back to 5. You get 50. Check 3, 5. Is there any here or not? Yes, you have 1, 3, 5 here. Skip. So 3, 5 clear. 3, 4. Sorry, 5, 4, 0. Start from station 4 back to 5. 4, 5, 60. So 4, 5, 5, 4. Is there any in the register? Yes. 4, 5 register already. Skip. So 5, 4 done. 5, 5, 0. 5, 5, 0. Really done. So for this exercise, they are 1, 2, 3, 4, 5, 6, 7, 8 pairs of composite. From the exercise we do, next steps, you see all this movement, right? Arrange from the highest number to the lowest number. Okay, arrange the composite based on movement. For example, 200, you pull to the top. You will get this new chart. I'll change this chart to this new chart. So the highest is 2 to 3, 200, 2 to 4, 150, 1 to 3, 110, 1 to 200, and so on. The highest to the lowest. Of course, you can build in a table in the full A4 paper size. Then you can see the, because I do this way because my PowerPoint slide have limited space. If I do it row, then the number will be very small and not presentable to you. Okay. So from here, any question? From here, any question on this table? You don't know how to build this one? Everyone good,
If the same value means
Which one? Oh,
the
the
15.
same menus means you can jump the sequence. Means for example, these two, right, is the same, right? So it doesn't matter you arrange 3-5 above or 2-5 below. It doesn't matter. You just arrange the movement based on their the highest you put to the top. The same number here, it doesn't matter you put 3-5 first or 2-5 first, doesn't matter. Okay? Any question on this table? Any question?
No, sir.
Okay, the next one will be very fun for those like arrangement things are like those who like to play chess game. The next one, we focus on this table. We evaluate based on non-adjacent load. Now try to give you some idea. Okay, pay attention to this table and also the original setting. Original setting. I'm going to redraw the original setting now. This is the original setting, right? 2 times 3 column, and it will be arranged by 1, 2, 3, 4, 5. Let's look at this table, and then we put in some lines or arrow. In this one, we put in lines first. First line. Do you see the red color I put there? First line. You see this one? 2, 3, 3, 2. I draw based on the table. The highest one, I go and focus first. So for example, this table 2, 3, 200, I go and focus on the original setting. 2, 3, I draw a red arrow. Or maybe in the test, you can use highlighter pen to highlight the thing. Or you can use maybe a broader thickness of pen. Maybe you can use a 1 mm kind of pen to draw this line just to differentiate from the grid itself. You draw the line, you put in numbers. Okay. After this table, you redraw back you copy the question grid. You put in the lines. 2 to 3, 200. You follow so that you don't miss out anything from the table. You follow the table first. 2 to 3, 200. Next, 2, 4, right? Go and focus on 2, 4. Why we can do this one? Because the forklift can do diagonal movement just now. Means you can move your chest. The forklift can do this way. 2, 4. Then you put in 150. You do the same for all the numbers. Just label and fill in the numbers. The third one, 1, 3. Where is 1, 3? 1, 3, right? Be careful. This is a special movement for non-adjacent loads. You draw a rainbow bridge between 1 and 3. You don't draw straight line from 1, then you don't draw lines from 1, cross 2, and then reach 3. If your line draw 1, 2, 3, it means 1, 2, and 3 process. Meaning you need to put in 1 double arrow, 2 double arrow, 3. Then it represents straight line. 1 to 3, it means only focus on process 1 and 3, or department 1 to department 3. You just draw a bridge between 1 and 3. And then put in a number there. 1100. This rainbow bridge, we call non-adjacent loads. What is adjacent load? This is called adjacent load. This is called adjacent load. Okay, the load that connected side by side means one step jump. Or when you play chess, you can only move one steps movement, right? So this movement, one step movement or one grid movement, we call it a Johnson loads. The movement that you need to jump cross one something, you need to jump like this, mean you need to connect by jumping or skipping one number. This called non-adjacent load. I hope you get the idea. Adjacent and non-adjacent. This is called adjacent. This is called non-adjacent. Okay, we continue with this one. 1, 3, 1, 2. Is 1, 2 relationship adjacent or non-adjacent? Shalini? Sarini? 1 to 3, sorry, 1 to 2. Is it adjacent or non-adjacent loads?
Adjacent.
Adjacent, because it's moved one unit only.
Yeah.
Okay, yeah, okay, put in 100. Okay, very good. You do the rest. 4, 5. 4, 5 also adjacent, You label 60. What about 2, 5? 2, 5 also adjacent. 2, 5. You fill in the value 50. What about 3, 5? 3, 5 also diagonal. 3, 5. 3, 5, 50. You draw a line, fill in 50 there. What about 3, 4? Can you jump? Or do you need to jump? Or can you? Yeah, you need to jump. Means there's another non-adjacent load from 4 to 3 or 3 to 4. The movement is 40. Okay, this is the first complete analysis for original factory plant. This is the analysis that you do. You have two non-adjacent loads in the process based on movement analysis. One is 1 to 3, another one is 3 to 4. This is the two area you want to minimize. You want to keep, the next game or next game that you want to play is to move around 1, 2, 3, 4, 5, so that everything become adjacent. Meaning you need to think which button or which station to move around, so that you eliminate the non-adjacent. You need to think. You need to think, because 1 is connected to 3. So can you move some of things and then you put it somewhere else? But it must be within the 6 position grid. Or means the six position here. 2 times 3 grid here. Okay, it will take some time to think about. Okay, since our time is almost there. So the next challenge or next game in this question is that eliminate the 2 adjacent by moving any of these numbers here, so that you eliminate the non-adjacent. Okay, so I just give you I give you the answer. So you try to think, because it will take you maybe 10 minutes to think about, because you need to adjust here and there. Yeah. So maybe I'll close the class here, and maybe you give me answer next lecture. All right. Our next lecture is on Wednesday. You try to think your homework from here. Of course, my PowerPoint, I will stop at here. I will give you the answer for today's slides. So you need to think, how do you move this 5 dot here, that you can eliminate 40 and 100? Means you can move around this 1, 2, 3, 4, this 1, 2, 3, 4, 5 point to eliminate the 40 and 110. Just give you some hints, because if you see this diagram, there's only three interest point that you need to move. With this 2 to 5, you don't need to move anymore. You can only move, not can only move lah. You can play around number 1, number 3, number 4. These are the 3 points that makes you problem. How can you move this point so that it become adjacent, loads, and you eliminate the jumping, this one, the need of jumping to cross the station. Okay. Of course, you can move around other 2 and 5 also if you want. I will give you some hints. Focus on number 1. Focus, the first starting point to do movement is that you focus on number 1, or maybe you fix point 1, and then you try to move around number 3 and number 4. Okay. Everything have to balance. The numbers here have to balance. But to give you hints, how do you move all these points so that this diagram become balanced? Or this balance eliminate the non-adjacent. There are 6 possible locations that you can go. 1, 2, 3, 4, 5, 6. And your movement, adjacent movement, you can move is this one, diagonal, up and down, diagonal. All right. So these are movements that you are allowed to do. Think about it. How do you fix this problem? How do you fix the non-adjacent? Think about it, and we discuss on coming class. Okay. With this, I end my recording.